Now let's have a look at some more complicated examples. So let's say one of those crossed things, yeah, just like we had incongruence, but obviously one side is larger than the other. We call this C, D, E, and A, B, C. The side lengths will be 6, 7.5, 10, 8. We want to prove that triangle ABC is similar to EDC. Of course, once again, if you recall, vertically opposite angle. So first thing, angle ACB has to equal to angle DCE because they are vertically opposite angles. And we'll have one angle now, and we also have the two matching sides given. We just have to verify the ratio between the matching sides. If it works, obviously it will be SAS because we have two sides and included angle. So let's try it. AC over EC. So 10 over 7.5, which is obviously 4 over 3. Yeah. And next one, BC over DC. BC over DC equals to 8 over 6, which is once again 4 over 3. Yep. And they're equal. Awesome. We have an angle, side, and another side. Both matching sides are the same ratio. So in this case, we can say, therefore, triangle ABC is similar to triangle EDC because SAS. Yep. Now, next one, there's an even higher level of complexity. So let's have a look at shape. A triangle that has a line through it. Yeah, and the two lines are parallel. So this one's 6, this one's 9, this one is unknown, it's W, and this one is 10. So we say that this one is K, this one is T, M, N, P. So first thing we have to do is prove that triangle KMT, so the smaller one, is similar to KNP, the larger one. Yeah. Once we have that, remember, just like in congruence, we use that as a basis to find something else. Hence, find W. So, what information have we been given here? Two parallel lines, yeah? And the angle is shared. So we can always start with what's been given, the most obvious one. So, angle T, KM is shared. Or common or whatever. Shared, common, the same thing. Now, if we look at here, yeah, because TM and PN are parallel, so we can say that angle KTM is the same as angle KPN. So this angle and this angle are equal because they are corresponding angles. Yeah. Because TM and PN are parallel. Next, of course, Okay, so Kn forms another transversal, the second transversal. So we say KNM, angle K, correction, KMT equals to angle KNP, because they're also corresponding angles. In fact, the reality is you only need any two of them, because triangles, their angle sum is 180. So if you find two angles, we are guaranteed to find the third. So to prove the angles of a triangle, you only need two angles at any time. So hence, so you choose any two of these and you just say triangle KMT is similar to angle KNP because they are equiangular. Yeah. Next step, hence find W. Yeah. Well, since we have established that these two triangles are similar in this step, then we can just use these two sides, these two matching sides, to find the ratio. And the ratio between other matching sides of these triangles will have to be equal as well. So we say let's put the large one over the small one. So Pn over Tm will have to be the ratio. So it would be this one over this one. Yeah. So we end up with something interesting. We're same as Kn over Km. Yeah. And in this case, obviously Pn is 9, Tm is 6. Kn here, we don't have a number, we just have a W and a 10 here. So Kn, the total length, is in fact W plus 10 and over Km, which is length of W. Yeah. Now, unfortunately, we have to go through the process of solving it algebraically. And we just say, here we just multiply both sides by W, multiply by W, multiply by W. So we end up with 9W over 6 equals to W plus 10. Yep. Multiply both sides by 6. So I'm trying to be as detailed as possible just to help you follow along. So we end up with 9W equals to 6W plus 60. Yep. And subtract 6W from both sides. We end up with 3W equals to 60, and obviously W equals to 20. Here is your answers.